Okay, we're going to talk about a special kind of function called the greatest integer function. So we have a couple different symbols that we use here. So we have y equals int, which stands for integer, so just int of x. Sometimes we see an x in this double square bracket notation. So that's the symbol behind it. Let's talk about a definition first. So the greatest integer function, this takes on any real number input, so that means our domain could be any real numbers, and it's going to return the largest integer. That's why it's called the greatest integer function. It's going to return the largest integer that is less than or equal to it. So before we look at this graph here, let's look at a few examples. So if we were to put in 5.3 into this greatest integer function, well, the largest integer that is less than or equal to 5.3 would be 5. The largest integer that is less than or equal to 5.9 would also be 5. Okay? 6 would not be the largest integer less than or equal to it. Okay, it has to always be less than or equal to it. If we put 4 into this special function, okay, we get 4 because 4 would be the largest one that is less than or equal to it. Okay. Negative 3.2, if you think about a number line, all right, negative 3.2 would be right about here between negative 3 and negative 4. So we'll need to create another piece here on our function for this value. So notice how the closed circle is on the left side and the open circle is on the right side. So this negative 3.2 falls onto that piece, which is why it's equal to negative 4. Likewise, 0.1 would be right there. That's equal to 0. Okay, so the graph looks like a series of steps. It's important to remember that you have an open circle on the, you have a closed circle on the left, and you have an open circle on the right. That is going to be true of every piece as you climb up or down this greatest integer function.